Hey everyone, today we are going to start section 2 of our unit on vectors, and I want to draw your attention to the warm-up here. Notice you've got a couple Khan Academy activities that you could use for a little bit more practice on finding the magnitude of a vector as well as finding a unit vector. So use those if you think necessary, okay? So section 2 is all about finding the dot product between two vectors, okay? And I want you to understand it's important to know that there are different types of products associated with vectors. So we've already looked at a scalar product, which is where you're taking a scalar real number and you're multiplying it by a vector. It just essentially increases the magnitude or decreases the magnitude of the vector, okay? But then between two different vectors, you have both dot products and cross products, okay? Now, we're probably not going to get to cross products just because of the shortened school year here, but I want you to understand it's not just enough to call it the product between two vectors. You have to be more specific, and in this case, we're finding the dot product, okay? So we'll get right into the formula for finding a dot product, okay? Notice I have two vectors, v and w here. They're in their standard unit vector form in terms of I and j. And the dot product is noted with v followed by what looks like a multiplication dot and then the second vector w, okay? So this is representing your dot product, okay? Again, there's a second type of product known as a cross product. That would look like this, okay? So notation is extremely important here, okay? Now notice we have a little formula here for finding the dot product. It's in red right here in the middle of the screen. So you're taking the two horizontal components of your vectors, you're multiplying those together. So in this case, a sub 1 times a sub 2. And that's being added with the product of the two vertical components, b sub 1 and b sub 2. Notice what that will result in. It will not produce a vector, but instead it's going to add up to a scalar. So the dot product between two vectors represents a real number scalar, okay? And therefore it's sometimes referred to as a scalar product rather than a dot product, okay? So I've got two specific vectors down below here. Let's begin by finding the dot product between vector v and vector w using that formula at the top of your screen, okay? So I simply just need to take the horizontal component of v multiplied by the horizontal component of w and add that with the vertical component of v times the vertical component of w. So that's going to give me 6 plus negative 20, which results in a dot product of negative 14. Okay, now let's find the dot product in the other direction. Dot product of w and v, that would just be 3 multiplied by 2. So now you're taking the reverse order of the horizontal components added with 5 times negative 4. That's going to lead to the same thing though, right? All right, so this shows us that the dot product between two vectors is commutative. And that should make sense because this formula, to find the dot product, it's utilizing both scalar multiplication and scalar addition, which are both commutative operations for real numbers, okay? Next, let's just find the dot product between a vector v and itself, okay? So this would be equivalent to 2 multiplied by 2 plus negative 4 multiplied by negative 4. So that's 4 plus 16 or 20. Okay. And lastly, I want to find the magnitude of this vector v, and hopefully we'll see a connection between its result and what we just found with the dot product of vector v in itself. Okay, so magnitude of vector v would equal the square root of 2 squared plus negative 4 squared, which is the square root of 4 plus 16, or the square root of 20, which we know can simplify, of course, to 2 radical 5, right? But I want to draw your attention to this. Before we simplified to 2 radical 5, we were at square root of 20. So notice if you were to square that, squaring this square root of 20 would just take you back to this dot product, right? Okay, so based on what we've observed here with those few examples, here are some properties associated with the dot product. So let's say we're working with vectors u, v, and w. Will the commutative property between two vectors, the dot product between two vectors applies. The distributive property would hold. So we're saying if I were to add vector v with vector w, and then multiply that, find the dot product between u and that resulting vector, that would be the same as if I found the dot product between u and v and the dot product between u and w, and then added those two results together. And then a couple more properties. So we just saw if you find the dot product between a vector and itself, that should just be equal to the square of its magnitude. And lastly, if you were to take the 0 vector and find the dot product between it and any other vector, it's always going to equal a scalar of 0. Okay? So that's all I wanted to cover in this video. What I would like you to do now, notice that the next sheet is a practice sheet. I want you to click over to that. You're going to try those on your own for a little bit of practice. Pause the video as you do that, and then when you finish, come back to the video, and I have the work already done out for you so you can check. Okay?